That class was something else. Those two kinds.
All right, do you guys need a minute? Or are you ready? You ready to share some? Ready? Okay. Let me turn on my pen. Oops. There we go. Okay, so what are some energies?
Kinetic.
Kinetic. What's kinetic energy?
Movement.
Good. Anything that's moving has kinetic energy, so moving. Good. Moving energy. Okay, anything else? Other types of energy.
Potential.
Good. Potential energy. So there's a lot of different types of potential energy. Which one are you thinking of? So, what do you think? So, what are you thinking of? Like, if I have something high and I drop it, then up here it has potential energy? Okay, that's called gravitational potential energy. Okay, gravitational. So that's based on the position relative to the ground or the bottom. Okay, so potential energy, gravitational. Anything else?
Sound energy.
Okay, sound energy. Good. So that's a compression wave. Good. So sound. Good. So sound can have energy. Yes, Brendan.
Elastic energy.
Okay. Elastic. So that's like if we have a spring that has a spring, if we squeeze it, that gives it some energy and it can do some work. Good, elastic energy. Okay, others.
Thermal energy.
Okay, thermal energy, good. This is an important one in chemistry. So another way to say this is just heat, okay, or the temperature. Good. Other energies.
Mechanical.
Radiant and mechanical. So radiant. Energy. So what are you thinking when you are thinking radiant? We'll come back to mechanical.
Oh, like the sun.
Okay. So radiant, or this is like, we'll put sun. And we're gonna spend a whole day talking about electromagnetic. Oh. Electromagnetic radiation. I'm not sure if the bottom is gone. I'm not sure what happened. Here we go. Great. It didn't go away. So have you heard of this? The electromagnetic spectrum. How many of you have heard of that? You heard of that? So this is just the different wavelengths of energy have different wavelengths. The different wavelengths have different energies. So we'll talk about this next after spring break. Okay, and you said mechanical energy. Good. Good. So that's like an engine does some work. It has the potential to do some work. Good. Other
Nuclear
energies. Nuclear energy. Good. So we talked a little bit about nuclear chemistry at the beginning of the year. So we talked about fusion and fission, and the energy stored in a nucleus. So nuclear energy is another one.
Did we ever say electric?
No. So electric energy or electricity. Let's put elect. Okay, that has energy. So everything we're doing in here, not everything, but like this board runs on electricity. Your Chromebooks run on electricity. The lights run on electricity. So that's a really big one for us. Brendan?
chemical energy.
Chemical, good. We're in chemistry. So chemical energy, and that's what we talked about last time. We talked about energy stored in bonds is known as chemical energy. Good. Okay. That's also how we get energy in batteries. Batteries are chemical energy in our cars. So good. Okay, other energies that you can think of. I think we have a.
Isn't
Really
elastic
good.
a type of energy?
Yep, we've got that one too. I think Brendan said that one. I think, or someone maybe someone up here said that. Okay, any others that you can think of? I think we've got a good list. Okay, very good. So we're just gonna scroll through and we can look and see if we missed any. Okay, we talked about that one. That's electromagnetic energy. Electrical energy, so that's just moving electrons. We talked about nuclear energy, gravitational, kinetic, thermal, sound. Okay, good. We got you guys even got more than that. All right, so conservation of energy. We've talked about conservation of mass. Well, so what is the conservation of energy then?
How much energy you have at the end of the experiment?
Good. So how much energy you have at the end? So we'll put energy at the end. What does that have to equal?
The energy you have at the end.
Good. The energy that we start with in a regular chemical equation. So if we start with some energy, we have to keep track of it. It has to go somewhere. We can't just lose it. Okay. So the energy we start with has to be the energy that we end with. Good. All right. So if I start with energy, or if I calculate I have some energy at the end, can that ever be more than I start with? No. I can never get, I have to account for the energy that I start with. Good. All right. So think for a minute with the people around you. What are some examples of energy transfers? Energy going from one type of energy to energy going to a different type of energy. So talk to your neighbors for a minute.
No idea. Trash. I know. It's also transformation. You didn't take this? Was it for that? How was that? Didn't take it, sorry.
For me, it was easy.
You went to both?
All right. Did you guys think of any examples? Energy going from one form to another. What did you come up with? Oh, you. Sure. If you want to share.
In a crash, it goes from kinetic energy to sound. No?
Okay. Yeah. So we had a car was going and then it crashed. It stopped. That energy had to go somewhere, and some of it goes into sound. Good. Okay. Also, there's like frictional losses. So we can lose energy, we just have to keep track of it along the way. Good. All right. Other ideas. How can energy transfer from one type to another type? Other ideas.
Potential energy and kinetic energy.
Okay, so that was like, we saw that picture of the dam. So the water is at the top, it has a lot of potential energy, and then it goes down, and it turns a turbine. The energy goes from kinetic to potential, and we get electricity out of that electrical energy. Good. Okay, other ideas. You guys are getting the hang of it? So we are, we need to understand that energy can transfer. We just can't, we have to have the same amount of energy that we start with at the end. Okay, good. All right, so I think we are good there. Let's think about our phone. So if we have our phone, what is the energy cycle for a phone? Where does the energy come from?
The battery.
Okay, what kind of energy is that? So a battery is chemical energy, chemical potential, yeah. So where does that chemical potential energy come from in your phone? Electricity, good. And that's electrical energy. Where does that electricity come from?
The wall.
Okay, where does it come from before that?
Like the wind turbines.
Okay, so a power plant, some kind of power plant. So you maybe yours comes from the wind. A lot of Utah is powered by coal-fired power plants. So that energy is chemical. The wind turbine, what kind of energy is that? Yeah, because it's moving. Yep, good. So we have kinetic going to turn a magnet. So there's some magnetic energy. Then we're getting electricity to the outlet to your chemical potential energy in your battery. And then you get out. What do we get out of a phone?
Light.
We get light,
Heat from time to time.
heat, sound. Does that make sound? Good. So good. Okay. So our assignment today. Okay, we talked about that. Oh, maybe we should talk about these. In chemistry, these are the main energies that we care about. We care about chemical energy, so like batteries, fuel, plants. So chemical energy. We also care about thermal energy. So we measured thermal energy when we did the EGNO-EXO investigation. Sometimes a reaction increases in temperature, sometimes it decreases. This is important. And another one that's pretty important is light. If a chemical reaction releases light, or we can use light to investigate our chemicals. So these are the main ones that we're going to focus on in chemistry. But today, I don't know if I have another slide. Or we'll just pull up our canvas. So today what I want you to do is I want you to get into groups. So no more than 3 in a group. So what we're going to do is you're going to pick something. So it can be your phone, it can be the light, it can be your car, it can be the dryer. So your group needs to pick a device and then map the energy. Okay? So we're going to have a lot of time for this, so I expect them to be pretty good. You need a picture with each part. So if I'm doing my dryer, I need a picture of my dryer. And then my dryer gets, maybe I have a gas dryer. So my gas dryer has energy from natural gas, which is chemical energy. So you need to label what type of energy it is, and you need to have a picture, and then show me how it's transferring. Okay, so like chemical to electrical to heat. Okay, all right, does that make sense? Okay, so this is going to be a group assignment. So remember, when we do group assignments, you have to go in through Canvas. So you can't be in a partner with somebody who's not here. So they'll just have to do it on their own. Move over here. So on Canvas, oh, I have to move this. You'll need to go to the people, oh, let's see, I think you can join. You might have to go to people. I forgot, I need to open this. So on the side panel, when I fix this, you'll be able to see people and you'll be able to join the correct group. I have to save. Okay, so now when you see, you should be able to see, yours is going to look slightly different, but you'll be able to go to people, then you'll be able to, we're like doing the energy transfer map. So you'll be able to jump in and you can only have up to 3 students. Does that make sense? So maybe my group is going to be group 1 and we all need to join that. So then only one person needs to submit the assignment. So this is something you could do on Google Docs. You could do, last time we worked through Adobe Spark when we did a group assignment like this. You could do that. They changed the name. Now it's just called Adobe something. So if you Google Adobe Spark, it'll still come up. So you could do like a poster through Adobe Spark. You could do a Google Doc, however you want to do that, okay? Or if you want to do it on paper, you could do that as well. You just have to have somebody who's going to draw it for you. Okay, questions on this assignment? So we're finding something, and I want you to go back as far as you can. You should have at least 6 or 7 different nodes in your diagram, okay? All right, I'm waiting for questions. No questions? Okay, go ahead and get in your groups and start. Yeah.
all the stuff.